I believe I can do it, but I just can't figure out how. Looking back on Cal, there must be a thing to apply now.
For a limit to exist at x equals c, we search for what is called continuity. Function on both sides will approach same y. From the left and the right, it's continuous, no gaps, holes, or jumps. It shouldn't be bothered by a little bump. Here's some steps to see if you'll continue. Here is what you should do. 1f of x must exist. 2, limit as x approaches c, I insist. Lastly, for 3, limit of f of c as x approaches c is equal to f of c. But wait, there's more. That's not the end. Non-removable discontinuity, you can't pretend. If a vertical asymptote is on the graph, it goes really tall like a giraffe.
Now that we understand limits, we can move on to the complex. I hope I'm ready, 'cause we've got derivatives next.
1, 2, 3, 4.
Everyone's derivatives and they weren't so bad. Remember all the rules and you never be sad. You want to differentiate x to the n, bring n to the front and take away 1 from the exponent. They ain't the opponent. But hey, what about products and quotients? V times u go to u to v plus v to u, and u over v is just the opposite. V to u minus u to v over v squared. It's just that simple, no need to be scared.
Now then, let's move on to trig. Just remember all these rules, it ain't no big. Sine goes to cosine, cosine to neg sine, tangent goes to secant squared to secant, secant tangent, cotangent goes to negative cosecant squared, and cosecant negative cosecant cotangent. Just to see, can it be? Derivatives are the best. Now then, let's put our knowledge to the test. Curve sketching, optimization, and related rates. Hey now, pay attention, don't be late. If you want to sketch a difficult curve, believe in yourself, you gotta have nerve. First you gotta look for discontinuities, asymptotes, and holes. You might have a few of these. Set the denominator equal to 0, find where that happens and you'll be a hero. If you can't simplify, then it's not removable, but if you can't, say goodbye, cause it's removable. Find these instances and plot them down, and get ready. We're about to go to town. Take the first derivative and find the points critical. We gotta make a sign chart, this is hypothetical. If f prime is negative, then f is decreasing, but hey, if it's positive, then f is increasing. If they happen back to back, you know what to do. Call it a max or min, there might be a few. Next we take the second derivative, find possible POI, and although it may be primitive, we gotta use these points to make our sign chart. Concave up or concave down, check that shopping cart. Put it all together, it's just that easy. Graph that function, it helps to use a TOV.
Hold up. Just took your steps forward, now take them back. The opposite of derivatives or integrals. Stay on track. Find position and velocity given acceleration. No need for hesitation or deliberation. There are 2 types of integrals, general and particular. This is quite literal. The first solution does not define c. Though the constant is unknown, you can't forget c. That's the first rule. Moving on to the next. X to the n integrates to x to the n plus 1 over n plus 1. Not complex, but n cannot equal negative 1. What happens then? It equals ln x. Now it gets more interesting the more factors you add. Use sub to reverse the chain, rule ain't so bad. Determine u, then derive and substitute. There's a missing factor, there's no need to reroute. Multiply by 1 for whatever you need. Factor out the fraction, you can integrate with the speed. Du gets integrated out. All that you're left with is nothing to mess with. If that's the answer you need, particular is key. Initial conditions could give you c. But with limits, we can use this rule called FTC. There are special trig identities that we could do, but they're just the opposite of what Jake told you. Bring it back to the integral limit definition. It removes inhibition on displacement and distance. Use upper and lower limits to evaluate the integral. Area must be positive in whatever interval. Average value, mean value, FTC2. These can be found with the integrals used. Engineers want to know about particle motion, displacement, and distance will give you the notion. Integrate when given acceleration. Given velocity, find the slope of the equation. Don't forget revolutions and curves. Upper minus lower functions will calm your nerves. Finally, don't forget your cross sections. Just integrate using a volume equation.
I got this.